So we're going to have a look at question 11 from exercise 2.2. I'm going to start off by just annotating this diagram here with the centres of each of the three circles. So there's a centre point here, a centre point here, and a centre point here. Now, if I join up those centre points, hopefully you can see that we create a single triangle. Now, the triangle has got to be equilateral because we're looking at the distances between the centres of identical circles. So if I sketch out that triangle, it looks like this, and the side lengths of the triangle effectively cover twice the radius because you're going from centre to centre of a circle. So that's 7 millimetres, 7 millimetres and 7 millimetres. So because it's equilateral, that means all three angles must be 60 degrees. So we can use this to work out the area of the triangle by using the half AB sine C formula, which is a half multiplied by 7 multiplied by 7 multiplied by sine of 60, which gives me 49 root 3 over 4 millimetres squared. So that's the area of this triangle. Now, look inside the triangle. Can you see there are 3 of these sectors here? And if we subtract the areas of these 3 sectors from the triangle, we're left with the shaded area in between, which we have to calculate in part 1. So my next job is to work out the area of one sector. Now, what do we know about this sector? Well, we know that it's bound by a radius here and a radius here. So this distance is 3.5 and 3.5 over here. And of course, the angle here is the same as the angle in the triangle. It's 60 degrees. Now, if I want to work out the area of this sector, I'm going to have to convert the angle into radians before I can use my area of a sector formula. Or I could just use the fact very simply that 60 degrees is 1/6 of the area of a whole circle. So I could just stay in degrees here and do the calculation quite simply as well. So the area of one sector is pi multiplied by 3.5 squared, and then I simply just divide by 6. Now the area of 3 sectors is effectively a semicircle. It's 3 lots of pi times 3.5 squared over 6. And then the shaded area left over inside, which I'm going to shade in purple. You see it here? The shaded area there. That's equal to the area of the big triangle take away the area of the 3 sectors. So that is 49 root 3 over 4, subtract 3 times pi times 3.5 squared over 6. Now let's work out what that comes to. So this gives us an answer of 1.9753, which is 1.98 millimetres squared to 3 significant figures for part 1. Now for part 2, we have to work out the length of the stretched band. So let's have a look at part 2. We're working out the length of the band when stretched. I am going to draw in some lines. Have a look at these. I'm going to draw in a line that runs from here to here, and a parallel line to that runs from there to there, both of which are equivalent to a radius. Now that creates a rectangle. Can you see it on the outside? And then we're going to do the same here and here, and the same here and here. So we now have on the outer section these 3 sections here, all of which are parallel to this section here and equal in length, which means they're equal to a diameter. So let's call these sections A. So A is equal to the diameter, so 7 millimeters. So to get the total perimeter, we're going to need 3 lots of A, which is 21 millimeters. Now, we then need to work out these lengths here, these arc lengths, and they're all in blue there. We'll label them B. Now, B is an arc length, and what we want to do is work out the size of this angle here, which I'll call theta. Now, theta is equal to 360 take away, and we know that this angle here is 60 degrees, so take away 60. And we know that these shapes here are rectangles, so these two green angles are 90 degrees, so take away 180. So that gives me theta equals 120 degrees, or 1/3 of a circle. So again, I could convert this into radians and get the arc length quite easily using the radian formula. And I could alternatively just look at the fact that the arc length is 1/3 of the whole circle. So the arc length B is 1/3 multiplied by pi multiplied by the diameter of the circle, which is 7. So that's 7 pi over 3. But of course we need 3 lots of B, which is 7 pi millimeters if we multiply that by 3. And then the total perimeter, or the length of the stretched band, is the 3A plus the 3B, which is equal to 21 plus 7 pi, which, if we work that out on a calculator, comes to 42.9911 ... or 43.0 millimeters to 3 SF.